Hey everyone, today we're going to crack one of algebra's biggest secret codes. That's really what factoring is, right? It's taking some big, complex expression and breaking it down into its simple, original building blocks. It's the key to turning a total mess into something clean and manageable. Okay, let's get into it. And this quote, it really nails the core idea. We all know that 2 times 3 equals 6. Well, factoring is just doing that in reverse. You start with the 6, and you have to find those hidden pieces, the 2 and the 3 that made it in the first place. We're going to apply that exact same logic, just with a little bit of algebra. So you can think of factors as being like the ingredients in a recipe. Factoring an expression is like figuring out what those ingredients are, the simpler parts that were multiplied together to create the final dish. Getting good at this is what lets you solve for variables and really understand how functions work. So with that foundation laid, let's start building our toolkit. All right, let's jump into our first and honestly our most important technique. I want you to think of this as level 1, the move you always have to try first, finding the greatest common factor, or as we call it, the GCF. The GCF is your master key. Seriously, before you try any other fancy technique, you've got to check for a GCF. It's the one thing that all the terms in your expression share, and pulling it out at the very beginning makes every other step 1,000 times easier. Okay, let's see this in action with 12x squared plus 18x. So for step 1, what's the biggest number that divides both 12 and 18? That's got to be 6. Easy enough. Now for step 2, what's the highest power of x they both share? Well, one has an x squared, the other just has an x, so the most they have in common is just a single x. That means our GCF is 6x. Now we just pull it out front, and there you have it, 6x times the quantity 2x plus 3. You can see how this is just like the reverse of the distributive property. And the best part? You can check your work. If you multiply that 6x back into the parentheses, guess what? You get right back to where you started. Perfect. All right, now that we have the golden rule down, it's time to level up. Great mathematicians are really just great pattern spotters. And in factoring, there are some awesome shortcuts you can use if you just train your eyes to see them. And the pattern you're going to see over and over and over again is this one, the difference of 2 squares. Now, the name might sound a little technical, but I promise the visual cue is super simple to spot. Here it is. Anytime you see a perfect square, a minus sign, and then another perfect square, it will always factor out into these 2 matching parentheses, one with a minus, one with a plus. Burn this visual into your brain. It's a massive time saver. So let's try one out. We've got 16x squared minus 25. Okay, let's check our boxes. Is 16x squared a perfect square? Yep, its square root is 4x. Is 25 a perfect square? You bet, its square root is 5. And are they separated by a minus sign? Yes, they are. We found our pattern. And just like that, the hard work is done. We just plug our square roots, the 4x and the 5, straight into that formula, and we get 4x minus 5 times 4x plus 5. See? Spotting the pattern makes it almost effortless. Okay, let's move on to our next challenge, expressions with 3 terms, which we call trinomials. Now, don't let these intimidate you. I want you to think of them as a fun little puzzle that we have to solve. Here's the puzzle for an expression like x squared plus 5x plus 6. We're on the hunt for 2 secret numbers. These numbers have to do 2 things at once. They have to multiply to give us the last number, which is 6, and they also have to add up to give us the middle number, 5. So let's solve this thing. First, what numbers multiply to 6? Well, we could have 1 and 6, or we could have 2 and 3. Now, which of those pairs also adds up to 5? Well, it's got to be 2 and 3. And that's it. We found our magic numbers. So the solution is just x plus 2 times x plus 3. Those 2 numbers we found just pop right into our factors. And boom, puzzle solved. Okay, so far so good, right? But what if you run into an expression that has, say, 4 terms, and there's no single GCF that works for all of them? Do we just throw in the towel? No way. We just need a new strategy. This next strategy is called factoring by grouping, and I love thinking of it as a team-up approach. If you can't tackle the whole expression at once, you just split it into smaller, manageable teams. Take a look at this one. First, we'll group the first two terms together, and then the last two terms. Now just look at each little group separately and pull out its own GCF. For the first pair, the GCF is y, which leaves us with y times x plus 2. For the second pair, the GCF is 3, leaving us with 3 times x plus 2. And now, look, it's like magic. A brand new common factor, the x plus 2, has just appeared. So we pull that whole thing out to the front, and we're left with our final answer, x plus 2 times y plus 3. Okay, it's time to put all of these skills together. We're going to combine a few of our methods to solve a problem that might look pretty nasty at first glance. So here it is, our final challenge, 2x cubed minus 8x. Yikes, it's not a trinomial, it's got a cube in it. Where in the world do we even start with something like this? We start with the golden rule. Say it with me, always check for a GCF. In this case, the GCF of 2x cubed and negative 8x is 2x. So let's pull that out. When we do, we're left with x squared minus 4 inside the parentheses. Now, does that look familiar to you? It absolutely should. That's a difference of 2 squares, our old friend. And that means we're not done yet. We have to keep factoring. The x squared minus 4 breaks down into x minus 2 and x plus 2. So our complete, fully factored answer is 2x times x minus 2 times x plus 2. See, we just had to peel back the layers one at a time. Hey, before we wrap up, a quick word of warning. Be super careful with negative signs, especially when you're using grouping. It's a really common trap. Also, don't quit too early. Like we just saw, you always have to check if your new factors can be factored again. And please, whatever you do, don't forget the golden rule. Always, always check for that GCF first. To help you remember all this, here's a super handy cheat sheet. It basically summarizes which method you should try based on how many terms you're looking at. From the all-purpose GCF to those special patterns and strategies, this is your entire factoring toolkit, all on one slide. So you see, factoring isn't just a boring set of rules to memorize. It's a way of thinking, a way of seeing the simple parts hidden inside complex problems. We've given you a whole toolkit today: the GCF, pattern spotting, solving trinomial puzzles, and the team-up grouping method. You now have the master keys, so the only question left is, which algebraic code are you going to crack next?